All right, so today we're going to be talking about graphing rational functions and some of the characteristics we're going to see, as well as some of the pieces that we're going to need to be able to accurately create our graphs. So, a few things we have talked about before with other topics, and these are asymptotes. So, remember that asymptotes are invisible lines in our graph that are kind of like borders that we're going to approach, but we're never going to touch. So, with what we're doing with graphing rationals, we could have three different kinds of asymptote. So, these asymptotes could either be vertical, meaning they're straight up and down, horizontal, meaning they're flat, or slant or oblique, which means that they are a line that has some slant to it. We'll talk about that in a second. So, to know if we have or where we have these asymptotes, there are some characteristics and some guidelines we have to run through. So, with our rational functions, we're going to typically have our function given to us as a fraction-like looking thing. So, we have a polynomial on the top, a polynomial on the bottom. So, what we do to find our vertical asymptote, so again, that straight up and down one, so we're going to solve. We're going to take our denominator and set it equal to 0 and solve for our variable. That will give us the equation of the line for our vertical asymptote. Now with our horizontal asymptote, we have three different possibilities. And it's really important that we're looking at our function that we're given for this. So if the degree is greater in the numerator, so the top of our function, then there is no horizontal asymptote. If the degree is greater in the denominator, then our horizontal asymptote is automatically y equals 0. If the degree on the top and bottom, so the numerator and denominator, are the same, then our equation for our horizontal asymptote comes from the leading coefficients of the numerator and the denominator. So for example, for this last one, this last graph here, so we have our function where the degree on the numerator and the denominator are the same. They both have an exponent, a highest exponent of 1 on our variable. So what we'd do is we'd take the leading coefficients. Remember, that's the number out front of the term and the term with the highest exponent. So we'd have y equals, we have 2 over our leading coefficient in the denominator is 1. We really don't need that 1 in the denominator. So that means our horizontal asymptote is at y equals 2, which is indicated here by this line. So again, these horizontal and vertical asymptotes are kind of marks that you're going to make in your graph that our graphs itself are never going to touch, but they're just going to approach. They're going to come very close to it. So the other one that we talked about, I mentioned before, was an oblique or a slant asymptote. So just depending on the problems you see, which will determine kind of which terminology you see. Now, you'll know you have a slant asymptote if you have the degree of our numerator minus the denominator is 1. All right, and you'll see that right here. So we have an oblique asymptote if the degree of a of x, which is the numerator, minus the degree of b of x equals 1. So if there's a 1 degree difference from the top to the bottom in our degrees, then we have a slant asymptote. Now, how we calculate that is by doing long division. So in this case, we would take, and I'm going to do this down here to kind of refresh on our long division. We would take our numerator, so x to the 4th plus 3x to the 3rd. And we are going to then take our denominator, so x to the 3rd minus 1, and we're going to do our polynomial long division. So again, I'm trying to figure out what I need to multiply the outside with to get the inside result. So x to the 3rd times what will give me x to the 4th, and that's just x. So x times x to the third is x to the fourth. X times -1 is negative x. All right, now we have, I'm going to actually write this a little more spaced out. So I'm going to write that negative x over here. All right, now we have to switch our signs to subtract this. So I'm going to switch those signs so that cancels. That's our goal. I'm going to carry down the next piece. So you have 3x to the third plus 0x to the second. All right, so remember we need those placeholders in there. So x to the third, I'm going to divide that into my 3x to the third. That would leave me with plus 3. 3 times x to the third is 3x to the third. 3 times -1 is going to give me -3. All right, again, I'm going to switch these signs so that I can do my canceling. And that leaves me with a remainder. And getting a remainder is okay, but all we really want to focus on is this part of our answer. All right, so I'm not even going to worry about the remainder in this case. Now, what this answer gives us is the equation of the line of the oblique asymptote or the slant asymptote. So if you look at our picture here, we have our slant asymptote already drawn in. So I'm just going to verify that, that's what it is. Now this is the equation of the line. So we have y equals x plus 3. That plus 3 is our y-intercept. So if you look at the graph, it's going by 2's. So in between those first two grid lines above the x-axis will be your plus 3 y-intercept. And then from there you go up 1 over 1. And again, since each box, each grid line is 2 units, we're going to utilize kind of the halfway marks in each of these grid lines. All right, and graphing that line will give you your slant asymptote. So we're going to be using this information to get some bounds for our graphs that we're going to be looking at, and then we are going to be using Desmos to kind of sketch the graphs, but I want you guys to be able to identify what kind of asymptotes we have and how we can calculate them. So here's just a kind of a summary I put together these next couple pages. So with a vertical asymptote, so these are all the things you're going to be solving for. You're going to set the denominator equal to 0 and solve. What that will give you is x equals something, and that's the equation for your vertical asymptote, that straight up and down line. The horizontal asymptote is when we have these 3 different cases. So if the degree in the numerator is bigger, we don't have a horizontal asymptote. If the degree is greater in the denominator, we have a horizontal asymptote of y equals 0. And if the degree is the same in the numerator and the denominator, we take the leading coefficients and put them over each other, and that becomes our equation. And again, I will demonstrate these things in a few of the problems ahead. The oblique asymptote is when we have a difference between the degree of the numerator and the denominator. So if we take the degree of the numerator minus the degree of the denominator, and that's 1, we're going to find the equation of that oblique asymptote by using the polynomial long division, like I just showed you. And then lastly, we're going to look at the zeros in the function and how we're going to solve for those. And remember, the zeros are where we cross the x-axis. We're going to take the numerator and we're going to set it equal to 0 and solve. And again, we'll look at that as well, but it's just going to give us some kind of landmarks in our graph as we're sketching that. And then right here, I did just want to note you will have and can have multiple asymptotes in a graph. Sometimes you will have just one with what we're doing, but sometimes you could have 3, for example. All right, and then this next page is, again, just another kind of helpful page to look at and kind of your steps that you're going to take to approach each problem. So first, you're going to find the zeros of the graph. To do that, you take the numerator, set it equal to 0, and solve. It'll be easier if you factor first, if you can. Then you'll have, that just means you'll typically have multiple zeros. And then you're going to find your asymptotes. So vertical, horizontal, and oblique. So I just went over how to find those. Now, when you're drawing these in on your graph, you want to draw them in as dotted lines. That's how we represent our asymptotes. And that's what you're going to do next. And then for step 4, you're going to create a table of values and sketch the graph. This year, I am going to allow you to use Desmos to get the sketch of the graph. So you'll input the graph into Desmos and then just sketch the picture of it. I'm not going to get too picky with it. What I really want to see you guys really master here is finding the zeros and finding the asymptotes and being able to sketch where the asymptotes are and then sketching your graph using Desmos. All right, so here we are going to look at the asymptotes. We're going to determine if there are any asymptotes, and if there are asymptotes, what are they? So we're given the graph, we're given the function. Let's just kind of go through our checklist. So for our vertical asymptote, in this first one, we're going to take our denominator and set equal to 0 and solve. So I have x plus 1 as my denominator. I'm going to set that equal to 0, and I'm going to solve to get x by itself. So I'm going to subtract the 1 from both sides to get x equals -1. That's my vertical asymptote. So where we're across the x-axis at -1, that's going to be my vertical asymptote. All right, now let's see if we have any horizontal asymptotes here. So I see my degree is greater in the numerator, so that means we do not have any horizontal asymptotes. All right, and then the last thing I want to look for is any slant asymptotes or oblique asymptotes. So I do see that the degree is 1 greater in the numerator than the denominator. So I'm now going to go ahead and do my polynomial long division. I have my x squared on the inside, and I have my x plus 1 on the outside of my division symbol. All right, I'm looking to see what times x is going to give me x squared, and that's just x. So x times x will give me x squared. X times 1 is x. I'm going to switch my signs here. That cancels. All right, and that leaves me with a negative x. All right, and then x times what will give me negative x, and that will be -1. So I get, when I multiply back through, -1 times x is negative x. -1 times +1 is -1. Again, I need to switch the signs to do my canceling, and I'm left with a +1. That's my remainder. That's okay. Again, that's fine. But what we care about is this right here. And that's the equation for our slant asymptote. So we're going to go down to -1, and then our slope is 1. So we're going to go up 1 over 1, rise over run. And you'll see that it nicely kind of follows. The graph is very close to that slant asymptote. All right, and that's that problem. Okay, so for this next example, we're going to look to see what our vertical asymptote is. So again, we're going to start back with the denominator. So I have x squared minus 1. I'm going to set that equal to 0. Now, a couple different things you can look at here. Now, I see this as a difference of squares. So remember, I can think of like taking the square root of the first term, square root of the second term. That's that a plus b, times a minus b format. So I'm going to end up with x plus 1 times x minus 1 when I factor this. So I'm going to take those, set them equal to 0. That'll leave me with x equals -1. And then I have x minus 1 equals 0. And that will leave me with x equals +1. So here we have 2 vertical asymptotes. All right, and I'm going to sketch those in at -1 and +1. now I'm going to look to see if I have any horizontal asymptotes. So I see that the degree is greater in the denominator. So when that's the case, remember our horizontal asymptote is just 0. It's the x-axis. All right, and then my slant asymptote, I do not have one here because the degree is greater in the denominator, so I don't have to worry about the degree of the numerator being 1 greater than the denominator. All right, and then last one here, let's see what our vertical asymptote is. So again, I take my denominator, x minus 3, set it equal to 0 and solve. So I get a vertical asymptote of x equals 3. And again, notice that our units here are going by 2. So that x equals 3 is going to kind of be halfway in between the first two grid lines off of the y-axis. Horizontal asymptote, I see that my degree is the same in both the numerator and the denominator. So that's when I'm going to take the leading coefficients in the numerator and the denominator, and that's going to become my equation. So if y equals my leading coefficient in my numerator is 2 over my leading coefficient is 1 in my denominator, and 2 over 1 is really just 2. So I have a horizontal asymptote at y equals 2. And then I have the same degree, so I don't have a slant asymptote. All right, so this is really the big chunks of what we're doing here. So I want you to be able to look at a graph, look at a function, and determine what, if any, our asymptotes are. And then you guys are going to be sketching this out as well, but this is kind of just to ease you into it. So here you feel free to look through this example. This is a worked out example. This page and the next one just have a few problems with step by step and how the graph came to be. All right, this next example here is one with a slant asymptote as well. And again, here's a review of some long division that you will need to be able to utilize. Again, notice here, sorry about that, they have a remainder, but it doesn't matter when it comes to graphing our slant asymptote, so you don't need to really do anything with that. All right, so let's look at this graph here. So we're going to look at this function, and then we're going to see if we can figure out our zeros and our asymptotes. So the zeros we haven't looked at yet, but I'm going to show that to you first. So it's very similar to finding the vertical asymptote, but we're just going to use the numerator instead. So to find our zeros, we take our numerator and set it equal to 0 and solve. So I have x to the third equals 0. Well, to undo that, I'm going to take the cubed root of both sides. All right, and that will give me 0. So I have my 0 of this function. I have x equals 0. All right, so that just tells me my graph is going to cross at the origin. All right, so let's look for our vertical asymptotes here. So again, for my vertical asymptotes, I take my denominator, set it equal to 0. So I have a vertical asymptote at x equals -1. All right, let's see my horizontal asymptote. So my degree is greater in the numerator. So that tells me that I don't have any horizontal asymptote. And then slant asymptote, I don't need to worry about that because the difference between the degrees is 2. So now what I would have you do at this point is to go to Desmos and put in this function and get the graph output, and then I want you to just sketch it using the landmarks that you have. All right, so for this graph, I have it in 2 pieces. So there's a piece that's like U-ish shaped on the left, approaching that vertical asymptote. And then I have another one that stretches both to positive and negative infinity on my right side. All right, so we're going to do the same thing for this next problem. And again, I want to start with the zeros of the function. Now, when I'm looking for my zeros, again, I am going to take the numerator and set it equal to 0. Now, when I have something that I can factor, I want to factor it first. So I'm going to factor the numerator. So x squared minus x minus 6. So I'm looking for two numbers that multiply to negative 6 and add up to negative 1. So I have negative 3 and positive 2. All right, so if I solve those, I'm going to set them equal to 0 and solve. I get x equals 3 and x equals negative 2. So these are my zeros of my graph. So these are the places that we're going to cross the x-axis. So at x equals 3 and x equals negative 2. So I know somewhere on my graph, somehow, some way, we're going to cross at these points. So for my vertical asymptote, I'm going to take that x plus 1, set it equal to 0. So I'm going to get x equals negative 1 as my vertical asymptote. All right, so I'm going to just sketch that in here. All right, for my horizontal asymptote, I do see that the degree is greater in the numerator, so that means that I will not have one. And then for my slant asymptote, I will have one because I have the degree in the numerator is 1 more than the degree in the denominator. So I'm going to use my long division here. So I have x plus 1, and then x squared minus x minus 6. So we get x times x is x squared, x times 1 will give us x. I'm going to switch those signs so I can subtract and cancel. So I have negative 2x minus 6. So x divides into negative 2x to leave me with a negative 2. Negative 2 times x will give me negative 2x. Negative 2 times 1 is negative 2. Again, I want to switch those signs, cancel. Negative 6 plus 2 will give me a negative 4. We have a remainder, but again, that doesn't matter to us with what we're doing. So my slant asymptote is y equals x minus 2. So to graph this, I'm going to go down 2, put a point, that's my y-intercept, and go up 1 over 1. All right, and that will give me a dotted line, roughly like this. And that'll be a slant asymptote. All right, and then the last step is, again, to just plug this in on the website and get the sketch for your graph and plot that out. And here's a rough sketch in red of what your graph would look like. All right, so we'll look at one more problem. So again, we're going to start with our zeros. So we want to take our numerator and set that equal to 0 to see what we have for zeros. So I have x squared equals 0. So take the square root of both sides. X equals 0. That means we're crossing at the origin. For a vertical asymptote, we're going to take the denominator, set it equal to 0. So I'd get x equals negative 1. Horizontal asymptote, again, my degree is greater in the numerator, so we don't have any for this case. But we will have a slant asymptote. So again, I'm going to do that polynomial long division. So we're going to x squared. We'll switch the signs. So I'd get negative x. So minus 1. All right, again, we got a remainder, but that's okay. Oops. X minus 1. All right, so again, that'll give me my slant asymptote. So I have my negative 1. And then I'm going to go up from there. All right, so for this graph, I graphed it in green, and you'll see that it kind of fits in between our two asymptotes. So that's one way that you will see these graphs, that they'll be like kind of snug right into the asymptotes. All right, and then from here all right, so one last thing I do want to go over, because I know you will see this in the homework, is a case of the polynomial long division that we may not have talked about. And it's going to yield some fractions in your equation. So if we had something like this, x squared x squared minus 8 over 4x plus 4. All right, and you had to do your polynomial long division. So I'm going to leave a spot for that plus 0x, and then I have my minus 8. So I want that placeholder in there. Now, what's different is we have to figure out what we're going to multiply that 4x by, right here, to get x squared. Now, I know that if I multiply x by x, I'm going to get that x squared. But I have to worry about this 4 now, too. And if I multiply 4 by 1/4, that's going to give me 1. So 1/4 times 4 will give me 1. So I'm going to multiply that through, and that will give me x squared, so 1x squared, so just x squared. And then 1/4 times 4 is 1x. All right, then I'm going to go through and switch my signs, cancel that. So I have negative x minus 8. All right, and I'm going to do the same kind of thing. What times 4x is going to give me a negative x? So that would be negative 1/4. All right, I'd multiply that through. That would give me a negative x. And then negative 1/4 times 4 would give me a negative 1. I'm going to switch those signs, so those would cancel. That would leave me with a negative 7, which would be my remainder. But this would be the only equation that I would be concerned about. So just know that sometimes you will have to utilize fractions when you're doing this polynomial long division. Your homework to work on. So what you're doing for each of these is exactly what we just did on those last 3 problems. So you start by finding any zeros, any asymptotes, sketch those out, and then sketch your graph.